Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. In this session, we are going to learn about pH scale and how to calculate the pH of a given solution. So, all the concepts regarding pH are discussed here. Let's start the session, right? So, we are discussing about what a pH scale. So pH scale was introduced by Sorensen. It is defined pH of a solution. Here pH of a solution is defined as negative logarithm of base 10 of the activity. Before this we have studied it in chemical equilibrium. What did we study? Activity, law of mass action, activity of some ion is nothing but concentration of that ion. Concentration of that ion. Here pH can be defined as pH is equal to negative log activity of hydrogen base 10. Activity of hydrogen base 10. Okay. Activity is nothing but in our syllabus we have activity means concentration expressed in moles per liter. Okay. Right. The other way of writing pH or other way of representing pH is pH is equal to minus log H plus ion concentration base 10. In simple language, if you discuss what is meant by pH, P means power, H power of hydrogen ion. What is that? Power of hydrogen ion. Where here you see activity of hydrogen means H plus ion concentration expressed in moles per liter. Right? And POH also you can write. POH, see, POH can also be defined as or can also be represented as mathematically minus log OH minus concentration base 10. POH is equal to minus log OH minus ion concentration base 10 or activity of OH minus ion. Activity of OH minus ion. In our syllabus, mostly we use this concentration, H plus ion concentration, OH minus ion concentration. You can also use activity, but for solving problems or for the expression, this way of expression will be comfort. So always we don't write base 10. Always we don't represent base 10. pH means when we write minus log H plus ion concentration, when we are solving or when we are writing, always we don't write 10. Actually 10 is there, base 10 is present. Base 10 is present. The definition is that pH is equal to minus log H plus ion concentration base 10. POH is equal to minus log OH minus ion concentration base 10. No doubt about it. Base 10 is there. Okay. So now when pH is equal to minus log H plus ion concentration, then what you H plus can be written as, what will be H plus? If pH is equal to minus log H plus ion concentration base 10, then what will be H plus? H plus can be written as 10 power minus pH. Can we write this? H plus is equal to 10 power minus pH. Is it possible to write? Is it possible to write? Let us see. So if pH is equal to minus log H plus ion concentration, okay, then H plus will be equal to 10 power minus pH. Or otherwise, let us multiply on both sides with the logarithm. Log H plus ion concentration is equal to log 10 power minus pH. Okay. Then log 10 power x is equal to x log 10. We know that. So log H plus ion concentration is equal to minus pH log 10 base 10. Always base 10, no? Here also base 10. So log H plus ion concentration base 10 is equal to log 10 base 10 is equal to 1 minus pH. Now I can write pH is equal to minus log H plus ion concentration base 10. Always it is not necessary to represent this base 10. So if pH is equal to minus log H plus ion concentration base 10, then H plus will be equal to 10 power minus pH. 10 power minus pH. In the same way, if I write pH is equal to POH is equal to minus log OH minus ion concentration, then what will be OH minus ion concentration? OH minus ion concentration will be 10 power minus POH. 10 power minus POH. Understood? So here pH is equal to minus log H plus ion concentration. So H plus ion concentration is equal to 10 power minus pH. So for any aqueous solution, the sum of the pH and POH depends upon the ionic product of water. Ionic product of water. And pH plus POH is equal to pKW at any temperature. At 25 degrees centigrade especially, pH plus POH is equal to 14. Okay. We know that ionic product of water. What is that? Ionic product of water is represented by Kw. And we have studied that Kw is equal to H plus ion concentration into OH minus ion concentration. Okay. Then multiply log on both sides. Log Kw is equal to log H plus ion concentration into OH minus ion concentration. Okay, so then this is equal to log A into B. Log A into B is equal to log A plus log B. So I can write it as log H plus ion concentration plus log OH minus ion concentration. Right? So this will be what? Log Kw. Then multiply with minus on both sides. Then what do you get? Multiply minus on both sides. Then what do you get? Minus log Kw is equal to minus log H plus ion concentration plus minus log OH minus ion concentration. Right? Then what do you get? We know that pH is equal to minus log H plus ion concentration. POH is equal to minus log OH minus ion concentration. And we can write P in the same way. pKw is equal to minus log Kw. All are base 10. So now I can write here pKw is equal to, okay, pKw is equal to, then what I can write? pKw is equal to pH plus pOH. So this is what it is written here. pH plus pOH is equal to pKw. pH plus pOH is equal to pKw, right? But at 25 degrees centigrade, that is 298 Kelvin, we know that Kw is equal to 10 power minus 14 mole square per liter square. Okay. So now only we have studied that pH plus pOH is equal to pKw. And we have studied that pKw is equal to minus log Kw base 10. Then write pKw is equal to minus log 10 power minus 14 base 10. Okay, that is equal to minus of minus 14 log 10 base 10. Log 10 base 10, log 10 is equal to 1. Minus into minus gives you plus 14. So I can write it as pH plus pOH is equal to 4. This is at 25 degrees centigrade or 298 Kelvin. So this is important. So here two formulae are important. What is that? One is pH plus pOH is equal to pKw. Another is pH plus pOH is equal to 14 at 25 degrees centigrade. At what temperature? 25 degrees centigrade. So that is what mentioned here. At 25 degrees centigrade, for any solution, aqueous solution, pH plus pOH is equal to 14. Understood? Understood? Right. Here, let us see. So pH scale lies between 0 to 14. So pH scale, it is a scale which contain units from 0 to 14. pH scale lies between 0 to 14. And at for pure water, neutral solution, pH is equal to pOH, that is equal to 7. That is equal to 7. Okay. So let us see that. Here we have already studied in the previous lecture regarding ionic product of water. We have studied that here H plus ion concentration. Let us see. H plus ion concentration, this is at 25 degrees centigrade. H plus ion concentration is equal to 10 power minus 7 moles per liter. Okay. For this pH is equal to how much? For this pH is equal to minus log 10 power minus 7 will be 7. pH is equal to 7. Okay. And OH minus ion concentration is equal to 10 power minus 7. Then for this pOH is equal to how much? 7. So this condition, what is this condition? pH 7, and this complete condition will be what? It will be neutral. What is this? This complete condition is considered to be neutral. Okay. What condition? Neutral. So pH is equal to 7, neutral. pOH is equal to 7, neutral. Right? Now only we have studied how to find pH. pH is equal to minus log H plus ion concentration. Here if you take pH is equal to minus log H plus ion concentration. So pH is equal to minus log H plus ion concentration. Now taken H plus ion concentration is equal to 10 power minus 7 moles per liter. This is at what temperature? At 25 degrees centigrade. Then substitute here pH is equal to minus log 10 power minus 7, 10 power minus 7. That is equal to minus of minus 7 log 10 base 10. Okay, you know that log 10 power x is equal to, what will you write? Log 10 power x is equal to, what will you write? X log 10. X log 10. Okay, based on that we have written here. So minus into minus, what do you get? Plus. Plus log 10. Already we have mentioned that it is base 10. Everything is base 10. We are speaking. So log 10 base 10 is equal to 1. So it will be plus 7. So pH. In the same way, pOH. OH minus ion concentration is equal to how much? 10 power minus 7 moles molar. Then pOH will be what? Minus log OH minus ion concentration. Okay. So pOH is equal to minus log 10 power minus 7. That is equal to minus of minus 7 log 10 base 10. That is equal to plus 7. Understood? So that is the reason why we have written here in this way. But if H plus ion concentration is equal to 10 power minus 7, then pH will be 7. If OH minus ion concentration is equal to 10 power minus 7, pOH is equal to 7. If it is minus 7, 10 power minus 7, when it is converted into pOH, it will be plus 7. In that way. Now this condition is for neutral at 25 degrees centigrade. If I increase the concentration of H plus, if I increase it to H plus ion concentration is equal to 10 power minus 6 molar. So now H plus ion concentration is more than 10 power minus 7. So it is acidic solution. This is acidic solution. If you calculate for this pH is equal to 6. Minus log 10 power minus 6. Minus log 10 power minus 6 gives you 6. Okay. Then what will be OH minus ion concentration for this 10 power minus 6 molar H plus? OH will be 10 power minus 8. Then pOH will be equal to 8. And we know that pH plus pOH must be equal to 14. So here 6 plus 8 is equal to 14. So what is this? H plus, as H plus ion concentration is more, the solution will be what? Acidic. What will be this? Acidic. So for acidic solution, pH will be less than 7, and pOH will be greater than 7. pOH will be greater than 7, not pH, pOH. In the same way, if I write here H plus ion concentration is equal to 10 power minus 5m, then automatically pH will be equal to 5. Then OH minus ion concentration will be 10 power minus 9. pOH will be equal to 9. Again, this is also acidic. So now, when pH is less than 7, that results in acidic solution. Because H plus ion concentration is greater than 10 power minus 7. This is all at 25 degrees centigrade. So let us go with 10 power minus 4 molar. Then pH will be equal to 4. Here OH minus ion concentration is equal to 10 power minus 10. pOH is equal to 10. This is also again acidic. Okay. Here in the same way, 10 power minus 3 molar H plus ion concentration, pH is equal to 3. OH 10 power minus 11, pOH is equal to 11. This is also again acidic, because if pH is less than 7, then that results in acidic solution. In the same way, 10 power minus 2 molar pH is equal to 2. This is equal to 10 power minus 12 OH minus ion concentration. In the same way, POH is equal to 12 acidic solution. 10 power minus 1 molar pH is equal to 1. Here OH minus ion concentration is equal to 10 power minus 13. POH is equal to 13. Again it is acidic. Right? In the same way, 10 power 0 molar, then pH is equal to 0. Here it is 10 power minus 14. POH is equal to 14. Acidic. Simple. You have to remember this. See, pH plus POH. So, for example, let us take the fourth one. pH plus POH must be equal to 14 at 25 degrees centigrade. pH plus POH must be 14 at 25 degrees centigrade. So that means here on moving down, what we are doing on moving down, what is happening? H plus ion concentration is increasing. Okay, so top to bottom, here especially here, top to bottom, H plus ion concentration is increasing. So acidic strength increases. pH is decreasing. What is that? This shows that on moving from top to bottom, acidic nature increases. What happens on moving from top to bottom? Acidic nature increases here in this situation. Okay. So now you say pH is equal to 6 and pH is equal to 1. Which is more acidic solution? pH 1 is more acidic than pH 6. A solution with pH 1 is more acidic than a solution with pH is equal to 6. Why pH 1 is having more acidic? Because its H plus ion concentration is more. More the H plus ion concentration, it results in more acidic solution. Solution. Right? That can also be asked in the terms of POH also. It can also be asked in the terms of the POH. So let us see that. Above this, let us see. Now OH minus ion concentration. Now OH minus ion concentration, let us take. OH minus ion concentration is equal to 10 power minus 6. 10 power minus 6. If OH minus ion concentration is 10 power minus 6, is 10 power minus 6 greater than 10 power minus 7 or less than 10 power minus 7? 10 power minus 6 is greater than 10 power minus 7. 10 power minus 6 is greater than 10 power minus 7. OH minus concentration. So this OH minus ion concentration is greater than 10 power minus 7 at 25 degrees centigrade. So when it is greater than 10 power minus 7, automatically it leads to basic nature. The solution will be basic nature. The solution will be no longer neutral. When it is 10 power minus 7 at 25 degrees centigrade, it will be neutral. Now it is greater than 10 power minus 7, 10 power minus 6. So it is neutral solution. So now I can write it as POH is equal to 6. So what is the solution? Basic. If you write H plus ion concentration and pH for this corresponding solution, now I can write it as H plus is equal to 10 power minus 8. 10 power minus 8 into 10 power minus 6 gives you 10 power minus 14. We know that. So on multiplying these two, 10 power minus 8 into 10 power minus 6, What do you get? 10 power minus 14. At 25 degrees centigrade, H plus ion concentration into OH minus ion concentration is equal to 10 power minus 14. Okay, are you getting this? So now what will be pH? So pH will be equal to, pH is equal to 8. If pH is greater than 7, if pH is greater than 7, the solution will be basic. If pH is greater than 7, it will be basic. Let us take OH minus ion concentration. OH minus ion concentration, still I am increasing, 10 power minus 5. So 10 power minus 5 is greater than 10 power minus 6. So now POH is equal to what? 5. So still it is basic. What is that? Basic solution. Because OH minus ion concentration is greater than 10 power minus 7. In the same way, for this corresponding solution, what will you write? H plus. H plus is equal to 10 power minus 9 m. This is what? All molar concentrations. What are all these? Molar concentrations. What are all these? Molar concentrations. Okay. pH will be equal to 9. So pH greater than 7 will be basic. Okay. Now OH minus ion concentration I am increasing to 10 power minus 4 m. So what will be POH? POH is equal to 4. Again basic. Okay. Now H plus ion concentration for this corresponding solution will be 10 power minus 10. So pH will be equal to 10. OH minus ion concentration here equal to 10 power minus 3 molar. POH is equal to 3. Again basic. Now H plus ion concentration for the corresponding solution will be 10 power minus 11 m molar. Then pH is equal to how much? 11. In the same way, let us write 10 power minus 2 molar OH minus ion concentration. POH is equal to 2. Basic solution. Here H plus ion concentration is equal to 10 power minus 12. pH is equal to 12. In the same way here 10 power minus 1 m. What you are having? POH is equal to 1. Basic solution. Here H plus ion concentration is equal to 10 power minus 13 m. pH is equal to how much? 13. Here H plus ion concentration is equal to 10 power minus 14 m. pH will be equal to 14. OH minus ion concentration is equal to 10 power 0 m. POH is equal to 0. Basic. So pH scale, if you see pH scale, where did it start? It started from 0. Started from 0 and extended to how much? 40. So pH scale have units from 0 to 40. Then pH is equal to 7, POH is equal to 7. At 25 degrees centigrade is neutral solution. pH less than 7, POH greater than 7. What is that? POH greater than 7, acidic solution. Right. Next, pH greater than 7, POH less than 7, that will be basic solution. Basic solution. Now you see, when we are moving from here up to 10 power minus 7, in this condition, when we are moving from bottom to top, what is that? Bottom to top. Bottom to top. When you are moving from bottom to top, what is happening? OH minus ion concentration increasing. OH minus ion concentration is increasing. pH is also increasing. pH decreasing, but pOH is decreasing. pH is increasing. You see 8, 9, 10, 11, 12. So OH minus is increasing. See 10 power minus 5, 10 power minus 4, 10 power minus 2. OH minus, when OH minus is increasing, then automatically more the number of OH minus or more the concentration of OH minus, more basic in nature. Is that more basic in nature? So what happens? Basic nature increases. What happens? Basic nature increases. Are you finding this? Okay. So cumulatively this is represented here in this format. What is that? In acidic solution, H plus ion concentration is greater than 10 power minus 7 molar. OH minus ion concentration is less than 10 power minus 7. pH is less than 7. pOH is greater than 7. Neutral solution, H plus 10 power minus 7, OH minus 10 power minus 7, pH 7, pOH 7. Coming to basic solution, H plus ion concentration less than 10 power minus 7, OH minus ion concentration will be greater than 10 power minus 7, pH will be greater than 7, pOH will be less than 7. So very detailedly we have discussed here, representing each and every point. Okay. So now if you go through this, then you can understand clearly. Once or twice you put it on the paper while listening the class, then it will be easy for which solution it is acidic, which solution it is basic, and which solution it is neutral. Understood? Right? Now let us see. We are calculating the pH of a strong acid or strong base. Calculating the pH of a strong acid or strong base. So here whether strong acid alpha will be equal to 1. What is alpha? Already we have studied that it is degree of dissociation. That means it dissociates completely. What happens? It dissociates completely. Alpha is equal to 1. Alpha means degree of dissociation. When it is equal to 1, how much acid you drop into water, for example, then complete acid will be dissociated. There will be no undissociated molecules. Strong acid meaning is that. In the same way, strong base, alpha is equal to 1. The meaning of strong base is also that alpha is equal to 1. Okay, for example, let us take HCl, strong acid. It dissociates into H plus plus Cl minus. If 1 mole per liter of HCl is dissolved in water, how many moles of 1 molar? Instead of molarity, it is better to study, or it doesn't matter. Molarity can be converted into normality. Okay. And we know that according to stoichiometric equation, 1 mole of HCl on dissociation gives you 1 mole of H plus and 1 mole of Cl minus. Then here 1 molar of HCl on dissociation gives you 1 molar of H plus and 1 molar of Cl minus. Okay, and we know that normality is equal to molarity. Normality is equal to molarity into N factor. Okay, in stoichiometry, we will study what is meant by N factor. Okay, N factor. Here, how many H plus it is producing? HCl. For HCl, N factor is equal to 1 because the number of replaceable hydrogens for an acid is called as N factor here. For HCl, N factor is equal to 1. So, normality will be equal to molarity because N factor is equal to 1. In the same way for H2SO4, N factor is equal to 2 because, for example, let us take H2SO4. H2SO4 on dissociation gives 2H plus plus SO4 minus 2. Okay, how many number of replaceable hydrogens are here? 2 replaceable hydrogens you are finding. How many replaceable hydrogens? 2 replaceable hydrogens. So that's the reason why N factor is equal to 2. So now normality is equal to, what you write? Molarity into 2. Molarity into 2. Okay. For example, let us take H3PO4. H3PO4. In the same way, N factor is equal to 3. Normality is equal to molarity into 3. In this way. So H3PO4 dissociates into 3H plus plus PO4 minus 3. So number of replaceable hydrogens are 3. How many are there? 3 number of replaceable hydrogens are. So N factor is equal to 3. So in the question, if it is given in molarity, you better convert it into normality. Without converting into normality, if you try to solve, you may be mistaken. For HCl, okay. But what about H2SO4 and H3PO4? Normality is not equal to molarity. So there will be mistake, there can be mistake done by you. Understood? So in the same way, base, strong base. So for strong acid, H plus is equal to normality of the solution. Here you see, H plus is equal to 1 molar. 1 molar is nothing but 1 normal. HCl solution. HCl solution concentration is equal to H plus ion concentration. That is what is said here. Normality of the solution, if I take it as 1 normal, then what will be H plus ion concentration? It is also 1 normal. So H plus ion concentration is nothing but normality of the solution for whom? Strong acid. In the same way for a base, for example NaOH. NaOH alpha is equal to 1, strong base. What is this? Strong base. When alpha is equal to 1, NaOH dissociates into Na plus plus OH minus. It is, how many OH minus? It is producing 1 OH minus. So what is that? N factor is equal to 1. If I give you the solution normality is equal to 2 normal, what is the OH minus ion concentration? 2 normal. That is what he says. For strong base, OH minus ion concentration is nothing but normality of the solution. OH minus ion concentration is nothing but what? Normality of the solution. Understood? Okay. So again, we have to understand that normality is equal to molarity into n factor. Based on this, we shall solve some questions. Some questions are given here, you see. First question, what is the pH of 0.005 m H2SO4 solution? Okay, so this is H2SO4 is strong acid. How much is given? Molarity of H2SO4, H2SO4. Its concentration, molarity is given as 5 into 10 power minus 3. We know that normality is equal to, okay, molarity into n factor. N factor for H2SO4 already we have studied now. What is it? 2. So molarity is equal to, molarity is given 5 into 10 power minus 3 into 2. So 10 into 10 power minus 3, that is equal to 10 power minus 2 normal. Why directly I am taking normality of H2SO4? Okay, normality of H2SO4 is 10 power minus 2 normal. See, directly I can take it as H plus. Directly I can take it as a H plus. Okay. Because before we have discussed that normality of solution, normality of acid for strong acid is equal to H plus ion concentration. Here normality, how much did you find? Normality of H2SO4 is 10 power minus 2, and that will be H plus. And we can say that pH is equal to minus log H plus ion concentration. That is equal to minus log H plus ion concentration is equal to 10 power minus 2. That is equal to minus of minus 2 log 10 base 10. That is equal to plus 2. So 2. What is the other way of solving it? See, H2SO4 dissociates into 2H plus SO4 minus 2. So 1 mole, see here 1 mole is producing 2 moles of H plus. Now how many molar is given? 5 into 10 power minus 3 molar. Here how much? 2 into 5 into 10 power minus 3. 2 5 is 10. 10 into 10 power minus 3. That is equal to 10 power minus 2 molar. Simple. The same you got 10 power minus 2. Okay. Molar. Molar here. Directly you can use this molar now. Okay. You can convert it in the form of normality, or you can convert it in the form of molarity in this way. So either the way you can solve. The same, directly you have taken this H plus ion concentration here and solved the problem as plus 2. Okay. Next, let us see the next question. What is that next question? What is the pH of 0.001 m aqueous solution of sodium hydroxide? Sodium hydroxide produces Na plus plus OH minus. As it is producing 1 OH minus, N factor is equal to 1. That means molarity is equal to normality. Molarity given, molarity is equal to how much? 10 power minus 3 m. That means normality is also 10 power minus 3 n. So before we have discussed that normality, see, normality of the base is equal to OH minus. So directly I can take it as OH minus ion concentration. This is equal to OH minus ion, 10 power minus 3 normal. So now we substitute here, but here asked is pH. We got OH minus. So we can solve it in two ways, but we can see one way. POH is equal to minus log OH minus ion concentration. That is equal to minus log OH minus ion concentration is 10 power minus 3 m. That is equal to minus of minus 3 log 10 base 10, which is equal to plus 3. So we got POH, and we know that pH plus pOH is equal to 14 at 25 degrees centigrade. Then pH is equal to 14 minus pOH, that is equal to 14 minus pOH we have calculated as 3, so that is equal to 11. So the answer will be 11. Sodium hydroxide base, for a base generally pH will be greater than 7. Okay, next pH of 1 liter solution containing 40 grams of NaOH. So molarity of NaOH, let us calculate. Molarity is equal to number of moles by volume in liters. Number of moles is equal to weight by, what is that? Molecular weight by volume of solution expressed in liters. So that is equal to weight, how much given? 40 grams by molecular weight is, gram molecular weight is 40 grams by 1 liter. 40 by 40, 1 molar. Okay, this can be also written as 1 normal, because for NaOH, N factor is equal to 1. What is that? N factor is equal to 1. And normality of base is equal to OH minus ion concentration, right? So now I can write OH minus ion concentration as how much? 1 normal. Okay, 1 normal. Now calculate pOH. pOH is equal to minus log OH minus ion concentration. That is equal to minus log OH minus ion 1. So log 1 is equal to 0. So pOH is equal to 0. Okay. Log 1 base 10 is equal to how much? Log 1 base 10 is equal to 0. Now I can write pH plus pOH is equal to 14 at 25 degrees centigrade. So pH is equal to 14 minus pOH, that is equal to 14 minus 0, that is equal to 4. So we have answer, right? So this is how to solve questions on pH when strong acid and strong bases are given. And we know that for strong acid and strong base, alpha is equal to 1, right? Hope so you understood this part of the topic, right? Each and every point, each and every single point I have mentioned you, I have represented. So slowly, this is a video. The fetching of this video is that you can rewind how many times you require. You can rewind it, you can play it. If you don't understand, again you can rewind it and you can play it. Whenever you are listening physical chemistry especially, you write it on the notes, because mathematical operations are involved here. Simply by looking at the lecture, sometimes you may not understand. When you put it on the paper, then you can understand it very easily. So you better, when you listen to the lecture, you put it on the paper, write it. Okay. Observe with keen. So keen observation is important here. Thank you very much for watching. In the next class, we shall continue the continuation of this pH value. Thank you. Let's meet in the next class.